So what if your brain had its own secret software, a hidden operating system with its own private language? Today, we're going to dive into the quest to crack that very code, the fundamental code of the human mind itself.
And no, I'm not talking about English or Spanish or any language you speak out loud. I mean the raw underlying code your brain uses to build concepts and just make sense of the world around you. A language of pure thought. Is it real? And even if it is, could we ever hope to read it?
Well, this idea isn't just some cool metaphor. It's actually a serious scientific theory called the language of thought hypothesis. And it suggests that our thinking is a kind of computation running on a mental language that researchers have nicknamed mentalese. The idea is it has its own vocabulary of basic concepts and its own grammar for combining them into really complex thoughts.
To put that a bit more simply, thinking is basically your brain rearranging mental symbols according to a fixed set of rules. Kind of like how a computer shuffles ones and zeros. That's what this quote means by the syntactic manipulation of symbols.
Okay, so if we have this hidden language tucked away in our heads, that immediately raises a massive question.
Right? If mentalese is locked away inside our minds, how on earth could we prove it's even there? It's not like you can plug a USB drive into your temple and read the source code. We need some kind of indirect way to find its signature, a trace it leaves behind in our behavior.
And just like any great detective story, this whole investigation really hinges on one crucial clue, a subtle pattern in how we learn.
That clue is called the simplicity bias. And the core idea here is that our brains, well, they're a bit lazy. They prefer concepts that are easier to build. So a concept like blue is simple. Blue and square is a little more complex. But a concept like, say, not blue or square and not large, well, that's way more complex. And because of that, it's a lot harder for us to wrap our heads around.
And this is how that bias becomes a really powerful tool. See, each possible language of thought, or LOT, creates its own unique fingerprint. Think of it this way. If your mental toolkit only has concepts for and not, the pattern of what you find easy or hard to learn is going to be totally different from someone whose toolkit also has or. The whole trick is finding a way to dust for those prints.
So, armed with this clue, researchers at the University of Amsterdam ran a simulation. They wanted to see if they could recover a hidden language just by looking for its fingerprint.
The setup was pretty simple. First, they gave a computer a secret language of thought. Then, they showed it a few items in a category, let's say things that are blue and square. After that, they asked the computer to guess which other items belong to that same category. All the while, a second program, the experimenter, was watching those final choices, trying to reverse engineer the secret language the computer was using.
So here's the big question. Did this kind of snapshot approach actually work? Was that fingerprint clear enough to identify the language of thought?
Not even close. I mean, as you can see in these charts, the results were just a messy, fuzzy signal. Each of these colored boxes represents the experimenter's belief about which language the agent was using. The fact that they're so wide and they overlap so much just means the experimenter was totally uncertain. It was basically just guessing.
And to put a really stark number on it, the success rate for correctly identifying the language of thought with any high confidence was a miserable 0.7%. The first attempt to crack the code, a total failure.
But hey, in science, failure is just data, right? So the researchers went back to the drawing board, and they came up with a new approach that led to a genuine breakthrough.
They realized the secret wasn't hiding in the final answer, but in the learning process itself. It's not just about what we know, but how we come to know it. If you track learning step by step, you can see which ideas the mind considers and which ones it throws away, and that reveals the very structure of its internal language.
This comparison just makes the difference so obvious. The first experiment was a single snapshot in time, but the second one, it was a movie. It showed items one by one, gave feedback after each guess, and traced how the agent's beliefs changed over time. And this created a much richer, way more dynamic stream of data that really captured the thinking process in action.
And the result of this new approach? Oh, it was a spectacular success. Just look at these new charts. See how the experimenter's belief, which is the height of these bars, just quickly zeroes in on the correct language. That fuzzy, uncertain signal from before was now sharp, clear, and totally decisive.
I mean, look at that jump, from less than 1% accuracy to over 91%. This proves a really profound point.
How we learn says so much more about our internal mental tools than what we ultimately know. The learning curve itself actually contains the code.
So, what have we learned from this whole scientific detective story? What does it tell us about our chances of actually decoding the mind's language?
Well, first, this work shows that it is possible to recover the language of thought from behavioral data. It's not just some philosophical fantasy. Second, the method you use is absolutely everything. You have to track the learning process. And finally, some mental languages just leave behind clearer fingerprints than others.
And that last point is fascinating. This chart shows how quickly different languages were identified. And notice how the languages over on the left, the ones with fewer conceptual tools like and, or, and not, were recovered much, much faster. A simpler internal language creates more predictable learning patterns, which makes it way easier for scientists to spot.
So why does all this matter? Well, because these simulations provide a roadmap. They show us how we can take a really abstract theory about the mind and turn it into a concrete, testable research program. This is basically a blueprint for how to decode the language of human reason.
And that leaves us with one final massive question to think about. If we finally build the tools to read this hidden language, to actually understand the source code of our own thoughts, what is the very first thing we should ask it?